Hi, I am Aditya Jha and this is my submission for the Valura AI Engineer assignment. I will walk you through how the system works, the key decisions I made, and what I would do differently with more time. Now, let me share my screen. So, this is the project root. All code lives in the SRC and all tests in tests file. So, you can see that. Now, let me walk you through how single request flow through the system. Now, everything starts from here. Main.py file. There is one endpoint post query. You can see that post query. It accepts the user's query, their user ID, session ID, and their full profile. The pipeline runs in this exact order. Like safety guard first, then classifier, then the agent, and the response streams back via SSC. There is a 30-second timeout on full pipeline. Now, first thing that runs is the safety guard. No LLM, no network call, just pure Python. It checks for harmful action intent across six categories: versus insider trading, market manipulation, money laundering, guaranteed returns, reckless advice, and sanctions evasion. Each blocked category returns a distinct professional refusal, not a generic message. Educational queries on these topics pass through the logic detects harmful intent, not just topic mention. This runs in under 10 milliseconds for any input. Now, if the safety guard passes, the classifier runs. This is one OpenAI call GPT-4 Mini during development. It returns structured output, intent extracted like extracted entities like tickets, amount, time periods, the target agent, and an informational safety verdict. That verdict is informational only. The guard is the only authority that blocks. The LLM call fails for any reason, the classifier falls back to general query with confidence zero. The request never crashes. Now let us go to portfolio.underscore The classifier routes to the right agent. Portfolio health is the fully implemented one. It receives the user's portfolio data, which is live prices via Y Finance, computes concentration risk, analyzed returns, and benchmark comparison. SPY for US portfolios, EWA for UK, and EWJ for Japan. It generates plain English observations, focus on the one or two things that matters most. Every response includes a regulatory disclaimer. And if the portfolio is empty, like if there is a user 004, it doesn't crash. It returns a build-oriented response, guiding the user toward their first allocations. Now, all other agents like market research, financial calculator, risk assessment, and so on. There are multiple. So these all are stubs. They don't crash. They don't return HTTP errors. They return a structured SSC response with the classified intent, extracted entities, and a message saying the agent isn't implemented in this build. The router's job is to route correctly even when the destination is a stub, and swapping in a real implementation is a straight drop in, no rewrites needed. Now, session memory is in memory a dict keyed by session ID storing the last 10 turns. Now let me start the server first. So now let me start the server. So as you can see that the server has started. Now let me open another terminal. Now like this. So so this is user 001, an aggressive use trader with 9 holdings. Now first event is metadata from the classifier. Now, live prices from Wi-Fi concentration risk benchmark comparison against SPY and plain English observation. Now, we can see that classifier correctly routed the portfolio health. You can see the concentration flag, the alpha against SPY, and two observations surfaced in plain English. You can see that. Now, so we can see it. We can use the same terminal, but since I'm recording this screen, so we can't see the below screen. So I am opening terminals again and again so that we can see it properly. So now user 004 has no holding, KYC complete, but zero position, agent doesn't crash, returns a build oriented response, guiding them toward their first allocation. Now, on another terminal. Now we can see that market research query routed correctly to market research agent returns structured non-implemented response internet entities are extracted correctly even though the agent is stuck. We can see the outputs like now let us run some tests like write test dash v. So sorry, my bad. Write test test. Now we can see that all 35 tests passed without an OpenAI API key. Now the non-obvious decision was the safety guard decision. The easy approach is keyword matching and topic. Block anything mentioning insider trading. The problem is that kills educational queries like what is insider trading should pass. My approach detects harmful action intent. The combination of first question framing plus an action go plus a harmful context like I work at Apple and know about an unannounced acquisition. So this is the first question. So action intent, confidential context. So what will the confidential context like? What is insider trading? Third person. This is the third person. Educational framing. No action. The trade-off is documented in the readme. Some edge cases over block, but at this layer, false positive are safer than false negatives. Like I also implemented two-step features. First, inter-session query deduplication, identical queries within the same session. Skip the LLM call entirely. Cache is keyed by session ID and normalized query string. Now, second, for tenant model selection, premium user ID set via environment variable. Get GPT 4.1, everyone else gets GPT 4 mini. One environment variable change to adjust, no code changes needed. So now everything is documented in README, setup, library choices with justification, pull request flow, safety trade-off, session memory decision, cost estimate, and performance targets. Now first token latency is under 2 seconds before because the safety guard is local. The classifier is a single LLM call and streaming starts immediately after. Now with another week, I would do three things. First is replace in-memory session storage with Redis. Right now, if the server restarts, sessions are gone and you can't run multiple instances. The second is to add an embedding-based pre-classifier for simple high-confidence queries like ratings or basic definitions. We skip the LLM all entirely. And the third one is that will add proper observability like latency histograms per agent, cost tagging per user, so the team can see exactly where the time and money are going. That's my submission. Thanks for the review.